All right, so this video is going to be on ellipses. So an ellipse is kind of like a circle that has been squished, basically, and we call these conic sections. So here's a picture from your resource packet. A conic section is what they mean if we were to take this shape as a cone, right? So we have a cone that goes up and a cone that goes down. If you were to take a knife and just take a slice out of the cone, what you would have left is a section of that cone. And so these are conic sections because they're different slices of cones. And there's different ways that you could slice a cone. So if you were to slice it kind of completely perpendicular to its opening, it would create a circle. If you were to cut it kind of slanted, that's how you would create an ellipse. So it looks kind of like an oval, but it's like perfectly formed, if that makes sense. It has a lot of symmetry to it. Parabolas, you guys have heard of those before outside of the context of conic sections, and then hyperbolas is almost like having two different parabolas. Okay, so we're going to study ellipses next. So we already looked at circles, and we're going to study ellipses. One way to name these is just to talk about conic sections, but they actually have some more interesting characteristics that define them, that make them have commonalities with each other. So the official definition, or like the really advanced and rigorous definition of an ellipse, is that an ellipse is the collection of all points in a plane such that the sum of the distance of any point to each focus is constant. So have that written down. We will look more in depth at that definition because it is, right now it feels a little abstract, so it's kind of hard to picture. But what we're going to do first is we're going to see the relationship between a circle and an ellipse, and then after that we're going to go ahead and start looking at the different vocabulary of what makes up an ellipse and the different types of things we're going to look for. So a circle, as we already learned, is written as x minus h squared plus y minus k squared equals r squared. And if you wanted to adjust this equation and make it equal 1, you could divide this by r squared, divide by r squared, divide by r squared. And so you could say the equation of a circle is x minus h squared over r squared plus y minus k squared over r squared equals 1. So we have two different ways of looking at the equation of a circle. The first one is to set it equal to r squared. The second one is to set it equal to 1. An ellipse equation is written very similarly to this version of a circle. So an ellipse is written as x minus h squared over a squared plus y minus k squared over b squared equals 1. And so the difference here is that instead of having r squared being the same, instead of having a radius that kind of goes all the way around the circle, well, that's like the distance between the edge of the circle and the center of the circle, you have this, and it's kind of the idea of like a radius, but not quite. So underneath the x, the a value is kind of like the radius, but only directly to the left and directly to the right. And then this is kind of like the radius, but only directly up and directly down, and then the distance between the center of the ellipse to the other edges would not be these numbers. But it's still an interesting relationship there, and it will help us graph these when we need to sketch them. So we're going to go ahead and write some information about the ellipse. We're going to say that the center for these is still hk. We're going to say that A is like the radius to the left and right. And we're going to say B is kind of like the radius up and down. All right, and so before we get deeper into all the different other points we can name of an ellipse, we're going to go ahead and graph one of these. So here's our example. We are going to sketch x minus 2 squared over 16 plus y plus 1 squared over 9 equals 1. And so that means that the center of the ellipse is the point positive 2, negative 1. And then after we graph that center to find other points, we're going to go to the left and right 4 and up and down 3. Okay, so let's go ahead and draw a sketch of this. So 2, negative 1, there's our center. And we're going to go to the right, 1, 2, 3, 4. And to the left, 1, 2, 3, 4. And then up, 1, 2, 3. And down, 1, 2, 3. So if my grid was perfect, this would look better. It's okay. So what you can see is it looks like a circle that's just been squished, right? So we have ellipses that can have kind of different orientations. This one is definitely wider than it is tall, and that's because the radius, you know, it's not really called a radius, but the number underneath x is bigger than the number underneath y. Okay, so let's go ahead and look at our packet, and then we can kind of see the ellipse and all these different vocabulary words that go with it. So these are all the different things that we're going to be finding, and this packet is really going to help you do that. So you can see that this A value is how far we go to the left and right, and then whichever one is more, if it's wide, you would say the vertices, vertex for one, vertices if you're talking plural. The vertices would go left and right, but if we're looking at this version where it's taller than it is wide, then the vertices would go up and down. So the vertices are whichever points are furthest from the center. Then we have co-vertices that are the ones that are a little bit closer to the center. So if we go ahead and use that to help us write some information about this ellipse that we just graphed, we would say that these vertices went left and right 4 from the center. So if I went left 4, that gives me negative 2. If I went right 4, that gives me 6. And then my co-vertices were up 3 and down 3. So if I went down 3, that'd be negative 4. If I went up 3, that'd be positive 2. Now, of course, I was counting it from here because my grid is not good, but if you were drawing this on a piece of graph paper and you wanted to look at the points from the graph paper instead, that would have been fine. Okay, so we have the center, the vertices, the co-vertices. We have some other points that are important from this. If you say it singular, talking about just one of them, you would call it a focus. If you're saying it plural, you could say foci or foci or foci. There's lots of different ways people pronounce it. Sometimes people like to say foci so they can say, what do foci? You know, get it? Okay. So whichever way you want to say it is fine. So that's what they were talking about in the definition when they said an ellipse is the collection of all points in a plane such that the sum of the distance of any point to each focus is constant. So I'm going to draw this in pencil, and you're welcome to draw it with me, or you can just look while I do it. But let's pick a point, and we would say maybe this point is right here. Then what they're saying is if you take this distance and you add it to this distance, you would come up with a number, some sort of number. And then if you were to take this point right here and take this distance and add it to that distance, you would get the exact same number. And if you were to take this point right here and take this distance and add it to this distance, you would get the exact same number again. So if you want to try that, I mean, legitimately get out a ruler and measure it in like millimeters or something, and you'll see that all those, the sums of those two distances really do add up to the same thing. All right, so that's like the true definition of an ellipse, how that shape is formed. Okay, there are some things that are not quite labeled on your picture here, and so we're going to label them. We have an axis of symmetry. We actually have two. And the one that goes from vertex to vertex is called the major axis. And the one that connects the covertex with the other covertex is called the minor axis. So when the ellipse is oriented this way, those are the names. And then when it's oriented this way, they're going to switch. So we'll say this one right here is the major axis. And then this one here is the minor axis. And so the major axis and the minor axis are pretty easy to find because they go through the center. And so whatever the x-coordinate of the center is, that's going to be that equation of the vertical line, whether that's the major axis or minor. The or the y-coordinate of the center is going to be this other axis, whether that's major or minor. So if we look next for the major axis and the minor axis, for this particular picture, the major axis would be horizontal, and so it would be y equals -1. The minor axis would be vertical, and so that would be x equals 2. Okay? And then we can go ahead and find the foci. So the way that you find the foci is they are always on the major axis. They are a distance of c from the center. Okay? And the way that you calculate c is you do c squared equals a squared minus b squared, or c squared equals b squared minus a squared, whichever one is going to give you a positive answer. So you do bigger minus smaller. So for this one, we're going to say c squared equals 16 minus 9. And so that means that c squared is 7. 16 minus 9 is 7. So c equals the square root of 7. And so that means if we were to go right square root 7 and left square root 7, that's how we would find our c value. And so I'm going to say that the foci or foci are going to be 2 plus square root 7, so go to the right, and 2 minus square root 7, so we're going to the left. All right, and those are exact answers, and when you give those answers, I do want them to be in exact form. Okay, so let's go ahead and do another one of these now that we know what all the words are. So here's the next example. We're going to sketch x minus 5 squared over 9 plus y squared over 20. All right, so we know that the center is 5, 0. And we're going to go left and right 3, and we're going to go up and down the square root of 20, whatever that happens to be. So I know that I have to have space to move to the right 5. Okay, so left and right 3. And then up and down the square root of 20. And square root of 20 is 4.472. So 1, 2, 3, 4.5-ish. That's not the center. Okay, so left and right 3, up and down 4.5. Okay, that kind of looks okay. All right, so for left and right 3 versus up and down 4, that means that the vertices go up and down, and the co-vertices go left and right. So I'm going to say up and down would be 5 positive root 20 and 5 negative root 20. The co-vertices, left and right 3, left 3 would be 2, right 3 would be 8. Okay. Our major axis would be vertical, so that would be x equals 5. The minor axis would be horizontal, so that would be y equals 0. Now they can also ask you things like, what's the length of the major axis? What's the length of the minor axis? And those are pretty easy to find. So if the minor axis goes this way, then you just count. We've got 3 and 3, that makes 6. Or we've got root 20 and root 20, so that makes 2 times the square root of 20. So those are other questions I could ask that are relatively easy to get. So to find our focus, we're going to need to do c squared equals 20 minus 9. We've got bigger minus smaller. 20 minus 9 is 11. So c is square root 11. You'll notice that here I'm not saying plus or minus when I do that square root, and that's because it's a distance, and so it's a positive amount. We know that the major axis goes this way, so that means the focus has to go up square root 11 and down square root 11. And so when we write the foci, we're going to have 5 positive root 11, 5 negative root 11. I think I found everything. There we go. Okay, let's do one more example. So this time we're going to write the conic in standard form. So, and this is what the conics look like when they're written in standard form. So if we look over here for the circle, you could say when it equals r squared, you could say that's standard form, I believe, or this is standard form. I might have to look into that. So they're going to give us the conic in general conic form. And so here's the general conic form is 4x squared plus y squared minus 8x plus 4y plus 4 equals 0. So the reason we call this general conic form is because when you're comparing like a circle versus an ellipse, just by looking at it, you can kind of tell, enough about it to be able to graph it. You can say the center, you can say the radius, all that stuff. When it's in general conic form, you could still start to learn those different pieces, but they're much harder to identify. So we would say it's general conic form because all of the conics can be written kind of this way and they're less recognizable. When you get the standard form of a circle or the standard form of an ellipse or the standard form of a hyperbola, they are much more recognizable. And so that's why we call this the general form. So the way that we take an equation that's written in general conic form and convert it into standard form is by completing the square. So what I'm going to do is I'm going to put all the x's together and all the y's together. So I have 4x squared minus 8x, and then I have y squared plus 4y. And then what I'll do is I'll take the number without a variable and I'll move that to the other side of the equation. So before I can do the completing the square process, I do have to take out this coefficient though. So I'm going to have x squared minus 2x. Okay, and then here I've got y squared plus 4y. That one's ready to go. Okay, so if I do the process of completing the square, I have to think about the b value, so the coefficient of x, I have to divide it by 2. So negative 2 divided by 2 is negative 1. Negative 1 squared is 1. And so that means I'm going to put plus 1 there. Now, whatever I do to the left side of the equation, I have to do to the right side of the equation. And even though it looks like I added 1 to the left side, I didn't really add 1 because there's this 4 over here that would be distributed to the 1. So I didn't really add 1, I actually added 4 times 1, which is 4. So now I'm going to add 4 to the right side of the equation. And then I'll use the b for the second part. So 4 divided by 2 is 2. 2 squared is 4. And so the 4 goes right up here. And since there is no coefficient for this one, then I can just say whatever I added to the left side of the equation, I have to add to the right side of the equation. And so now I'm ready to kind of write this in completed square form. So I do have the 4 in the front, and then whatever I got when I divided by 2 is part of what goes in the parentheses. So this would be x minus 1, and this would be y plus 2. And then that's positive 8, and negative 4 makes positive 4. Now at this point, to continue and finish the problem, if this was a circle, then it wouldn't have a coefficient for either of these parentheses, and you could have just left it, but since it's not a circle, I know that because of this 4, and I have to make this equal 1. So I'm going to divide by 4, divide by 4, divide by 4 to make that equal 1 right there. And so these cancel. I have x minus 1 squared. Now, if you want, for this unit, you could put over 1 just to help you think about, that means that that radius to the left and right would be 1. If you don't want to write that, that's fine. You don't need it. Just find that it kind of helps sometimes. And so this would be the standard form of the ellipse. It's centered at 1, negative 2, goes left and right 1, up and down 2, and then from there we could draw the graph and find all the other information.